Hello, everyone. Welcome to our final AIxCC team interview of CTF Radiooo. I'm Adam D, and like always, I'm here with Zardus. Zardus, say hi.
Hello, hackers. I'm super excited to get this. The seventh of 7 episodes of talking with the AIxCC teams. This is super cool. When we first had the idea that, hey, we should actually talk to all the AIxCC teams, see what's up, see like how people are, had prepared for the competition, had participated in it. It didn't actually occur to me that all 7 teams talking to everybody would be a possibility. I was sure that we could do 4, probably. Yeah. But it's been awesome. Awesome to see the response. Everyone is like, hell yeah, this is a great idea.
Don't sell yourself short. You were the one that had the idea of interviewing all the teams. It was after our Shellfish interview. You said, well, why don't we just do this with all the teams? And I said, because that's insane. Like, why would we? And also like you, I thought like, well, will the teams even want to talk about this stuff? But I think giving them the platform to be able to talk about the cool stuff they've built over the last year, 2 years have been super valuable. Plus, I think maybe built into the competition itself, because there's the mandatory open source requirement. Every team knows that their stuff's going to be open source anyways, so there's not really a whole lot in terms of trade secrets that people need to be worried about, which I think looking back maybe at CGC, you would have seen more of that and more reluctance to kind of go into depth about this stuff.
Yeah, and there wasn't a podcast like this back then, but one thing that we did do right after the CGC was kind of put out feelers to the other teams. Hey, is there any interest in a joint paper about the design of a cyber reasoning system? And you definitely felt this sort of, yes, but we can't really talk about anything. Which, I think the open source requirement really, like you said, made an interesting change too. That was very cool.
Yeah, exactly. It definitely makes the contest more open, and I think the participants more willing to talk about what's going on. Now that we've submitted, I think that's what the other thing we talked about is right after quals, we had wanted to do this, but we have our first mini guest on the podcast. And we'd wanted to talk to the teams after quals, but we're like, who's going to talk to us? Even when we talked to our own team, Shellfish, they were very cagey about saying what we did or didn't do, because everyone wants to hold on to their secrets until finals, because, you have a chance to win $4 million. So it makes sense. All right. All of that. We have our last but definitely not least team. I think they had the best excuse for recording the latest as possible. They were on vacation and traveling like after the final submission. So this was a welcome thing to hear, that people are actually like taking time off after this push of the AIxCC finals. So we have with us All You Need Is a Fuzzing Brain, which I'm also very interested to learn more about this team just based on the name. We have 3 folks with us today, so why don't we go in order and have everyone introduce themselves?
I'll go first. This is Jeff Huang. I'm a professor from Texas A&M. I'm the tech lead of our team. All You Need Is a Fuzzing Brain. We're going to talk about, why the name, like that later. But anyway, first of all, thank you, Adam and Yam, for doing this. This is super great for this community. Actually, we're very, very excited to join this show.
Awesome. Yeah, we're very, very happy to have you. Like I tell my wife and my family, we have hundreds of people. We have like a very, very targeted podcast, but I think that it's of interest to that targeted people.
Well, I'll go next. My name is Z. I'm currently a PhD student in computer science at A&M University, working on the quantum supervision. Well, I feel really happy to join the podcast. I actually watched a bunch of previous podcasts made by you, and wow, I got tons of inspiration, because I'm relatively new to this field and got tons of philosophy on how to design a good CRS, right? And I mainly focus on testing the whole CRS. So here we go.
So you're the fuzzing brain. Actually, we'll get into it, but
testing, well.
There you go. Yeah, somebody has
Keep
to test.
It simple and stable. Huh?
I try.
Yeah, you only have so much power.
Yeah, that's right.
Qingxiao?
Yeah, hi. My name is Qingxiao, and I'm a first-year PhD student at Texas A&M. And I actually joined this team at the beginning of the year because I was working on another project which has, well, I'm working on basically the same thing with static analysis, and Jeff had the great idea of that it's very relevant and you should definitely join this competition and learn more about RCRS. And I'm so excited that he asked, and after learning the whole architecture of our CRS system, I was really grateful for this opportunity, the competition, and yeah, I'm really excited about our podcast cast today as well. Yeah, I'll talk more about the relevant part that I'm working on.
Cool.
Very cool. Wow. So you guys have I love this. We have a diverse set of people here, right? So we have the tech lead professor and people who just joined within the last year. So that's really cool. I love that. So maybe oh yeah, go ahead,
Sorry,
Jeff.
yeah, I just want to add, we also have some super, good undergraduates.
Wow.
Matthew
That's cool.
Woodward, unfortunately he has a conflict, but he'll be at the DEF CON conference.
Awesome. Well, that's a great segue. So maybe you can talk to us a little bit about the team itself. So because I think part of what so many people, it's so hard to see from the outside is what is the composition of these teams. So maybe you can talk to us about what the composition of the team is, rough size, how it came about, that kind of stuff.
Yeah, we have 8 people on the team. Mostly are connected, through various, over the years of collaboration. Majority my students, and my collaborators. I think six of them are Texas A&M people. A couple of from the programming language and software engineering community. I've had a bunch of collaboration before. Starting from the semi, finals, kind of, there's some new people joined as well, including Qingxiao. Yeah, so that's the rough description of this team.
You guys are one of the few unabashedly purely academic teams in the competition, as far as I can see. So, there's, because of the way that DARPA was and RPH were able to kind of add incentives into the competition, there was a lot of companies, small businesses that competed. And in fact, some small businesses were created by otherwise academic teams to compete in the competition. But I'm trying to think if this is accurate. I think you guys might be the only purely academic team without a small business entity attached at all.
Yeah, I think that's true.
Yeah.
I mean, Shellfish does 42 Beyond Bug. I think the other academic team is Team Atlanta, but they have heavy support from Samsung. It's not official, but for sure they're using a lot of Samsung engineers, which I assume you're not using any engineers from a company. But yeah, that's super cool. That reminds me of Shellfish in the CGC kind of.
Mm-hmm. Yeah, it's this underdog situation because, of course, the way that our society, even from a research perspective, is set up. People expect, okay, the researchers, like in the universities, they're going to create the initial ideas, and those ideas aren't going to work, and then someone will go in and take them and put them in a company setting and make them work, right? Whereas I think people like you guys stand up and say, hey, no, we're going to actually make this work. And that's what, in the Cyber Grand Challenge, what we did at Shellfish. It was, there were maybe 3 purely academic teams in the CGC. And I think part of that was just a different set of incentives for how the funding flowed. Out of those, there was a wide variety of outcomes, which was very interesting to see how that goes. So I guess kind of preliminary question, what do you feel about that being like one of the few examples of pure academia in the competition?
I didn't expect that, lots of companies involved in this competition. I think we're very, very lucky, actually in the semifinal, I think we wrote maybe just a few hundred lines of Python code, just completely based on large language models. There's zero fuzzing at all.
I saw it in the competition, in the actual semifinals. We were at the ceremony, and I think Andrew Carney said that your CRS had the lowest fuzzing, which I guess no fuzzing. That's awesome. That's really amazing.
Yeah, but then in the finals, gradually realize, there's too much engineering, tons of engineering. I guess open source really helped. AI really helped because I think look at our code bases, probably more than 90% of the code written by AI.
Wow. Okay, this is great. I love this.
And of course, we use a lot of open source libraries, including some static analysis framework. I think one of them is called SVF. We can talk more about it.
This is great. So, okay, this actually sounds like a very great return on investment. So, 100-line Python submission got you $2 million, right?
More than 100, I guess, maybe 500 or something.
That's awesome.
Still pretty good.
What's really cool is between the lines of that, harnessed correctly, 500 lines of code, of Python code, can actually be effective at finding and fixing vulnerabilities, which you had to do in order to qualify. Which that's amazing. Like that is, if anything, maybe the best kind of expose of the state of the impact of AI in cybersecurity.
And so was this, because this is great. Maybe we can dig in. So like the approach for quals was just purely LLM-driven approach. Wow. Was that like deliberate? Like, is it based on your backgrounds? You thought like, well, let's just do this, or I don't know, like what led you to that direction?
I think at the very beginning, I was already super passionate about the capabilities of large language models. I had a little bit into fuzzing AFL ++. I tested on some very tiny examples. It took hours for it to find something meaningful. And then it take maybe just a few seconds at that time, I think, I forgot it's GPT-4o or something like that, to find the vulnerability immediately. So.
I think this makes you unique, actually, among the contestants. We hypothesized early on in the series that there's going to be two approaches. One, people will start from the cyber reasoning systems of the Cyber Grand Challenge, the fuzzing, et cetera, and move toward the AI space. And the other approach is people start with AI and move toward the other side. And it sounds like you started from the AI and moved from there. Theory is probably the closest in that approach, but from talking to them, it didn't sound like they started with purely AI. I think
they wanted to, right?
Yeah, they wanted to.
Yeah, they approached it from a very AI heavy approach, but they definitely didn't start with a full just AI approach, as I understand it.
It's super cool to hear. This is great.
This is awesome. Okay,
what's really interesting to me too is I of course, I'm familiar with your publication record, and there's a lot of software engineering, programming languages, these very, algorithmic, deductive reasoning about code, not inductive reasoning. And it's cool that, the AIxCC popped up and you're like, aha, totally new approach.
Yeah, I have to say, I did a lot of point analysis in the past. I think one instance in this particular competition, I realized, building the systems, building the tools for point analysis, it's very, very challenging for complex projects like, Linux kernel, we spent a huge amount of time actually building static analysis in the finals. And in the end, somehow I realized the point analysis, you should use the most, simplest point analysis to do this type of thing. versus in the past where we're talking about object sensitive, interprocedural, yeah. But anyways,
And is there intuition behind that you just need to give the AI a small push and it does the rest?
it's just the systems, the point analysis is very fragile for complex projects. It doesn't scale too much. For example, it can easily take, I remember there was a project called Coral, CRL. Yeah.
We're very well familiar with this monstrosity.
And the AI, so we use LLVM, IR, it easily generated like 30 megabytes of bit code. And then took maybe 20, 30 minutes to just analyze, to generate call graph for it. I mean, our system could not wait for 20 minutes for the static analysis to finish and to do anything, right? So we had to optimize it. We have to parallelize a lot of things. Yeah, in the end, we try to manage everything to finish within 5 minutes, before we actually do anything.
Okay, great. So maybe before we dive in too much in technical details, maybe we could go back. So can you explain the team name?
Okay, all you need is a Fuzzing brand. Okay,
yes, but you didn't use fuzzing when you submitted. This is what I'm confused about.
Exactly. I think the security community, they're all happy about fuzzing, right? I mean, I was aware like Google, had like thousands of machines fuzzing 24 hours. For Google Chrome releases something like that, right? And then Google also published a famous paper. All you need is transformer. I really love that paper. I read it with a lot of curiosity and excitement. So I think just a couple months before the semifinal, I started looking into it. Say, oh, we need a team name for it, right? Then that just popped into my mind. And then one thing I did not, very clear about was what is the role of AI there, right? So and then I created Fathom brand. I really think AI is the brand. So that's how all things are, are connected. So I consider AI is the brand and Fuzzing is a methodology in the traditional sense of security, bug funding. So if you have a super powerful brain involved, in doing all this strategies, planning, you should create a more powerful system for that. So that's the origin of this, name.
That's great. Wow, awesome.
Very philosophical.
Yeah, I like it. So then maybe we can. So okay. Does your cyber reasoning system have a name? Speaking of names,
same name.
All you need is a fuzzing brain.
Is
also
CIS.
Fuzzing brain, I think. It's CIS, right?
Wait, Jed, did you say the brain? The brain would be a cool cyber reasoning system. The brain is having issues.
Yeah, I think sometimes we call it fuzzing brain.
Fuzzing brain, okay.
But just when we write things with CIS, but officially it's the same name as.
All you need is fuzzing brain. AYN.
Yeah, you're trying to make an acronym out of it. You should just ask an LLM. But that's what they're good at.
Yeah, exactly. That's good.
Cool. Okay, so then maybe somebody can give us kind of the high-level overview of a fuzzing brain, the final submission. So what's kind of like the 1,000-foot technical view of the things the components that you have?
Well, sure. Well, when DARPA first announced the challenge format with the send receive methodology for the final competition, I think we immediately decided to go with a multi-web service architecture. Like for our CIS, the core requirement is to process tasks quickly and efficiently, right? So basically, we designed 4 main services. The first one is task service. This service primarily reasonable for parsing and building challenges, and then distributing tasks to worker service, which is another one. And it actually acts as the central controller that manages the incoming challenges. and make sure everything is distributed correctly. And then for worker service, and this is where the actual processing happens. Worker services handle the assigned task by running different strategies, and all of the strategies are Python scripts, which means that we run Python script in our services. And these Python scripts are designed to find POVs and patches like we used to do. And each worker can execute multiple strategies in parallel. And all the workers are actually run in parallel. So it's a parallel in parallel. Yeah. And the third one is called submission service. You can think like this is an agent between our CRS and the organizer's submission endpoint. Well, in this service, we actually manage deduplication here, and we maintain all discovered POVs and patches. And also we perform serif analysis and handle the bundling functionality. And this is what it does. And for the last one, which is static analysis service, and this is the one which provides function metadata retrieving and call path generation by CodeQL or other static analysis tools. These 4 services are actually the basic framework of our CRS. And other than that, there are actually 13 or 15 different POV and patch generation strategies. And these strategies are the real script that will generate POV and patches. And also we have fuzzing in the final. Yeah.
So you do have a fuzzing brain now. Great.
Yeah, we do. Yeah.
What made you add it?
Well, we have to add it as a basic strategy. So like if we have a valid POV, it's valid, but it doesn't trigger the vulnerability, and we let it be the seed that's stored in the corpus, and let the father run this seed. Yeah.
So basically, to take maybe hypotheses by the LLM and turn them into reproducible triggers for a vulnerability.
Yeah.
That's great. So you mentioned different strategies. So how did you come up with these different strategies? Was this kind of manually crafted? What was the nature of different strategies? Maybe we can dive into there.
Well, it depends. Basically, it depends on the execution speed and cost. So for some simple challenges, we want to find POVs and patches really fast, right? So we probably need to design some strategies that has a 0-shot or 1-shot usage of large language model, which can generate correct result immediately. And for some complex ones, we have integrated with a static analysis, like we generate call trace from the entry point to the target function, and we can, these are for some difficult challenges. Yeah, it depends on the difficulties and the cost and some other trade-offs. Yeah.
Nice.
You want to add something?
Oh yeah, go ahead, please.
Dr. Huang, you want to add something?
So maybe before we go into too much detail,
yeah.
at a very high level, call to our CIS is parallelization. So we actually statically allocated maybe 100 VM instances, from 32 calls to 192 calls. So on each VM instance, we have maybe hundreds of threads running. So it'd be thousands of threads, running in parallel each time. We actually, I look at our line of code, not only in Python, right? I think half of the code is actually written in Go.
Yeah.
We pick
Wow,
Go
interesting.
because Go has a very good concurrency control, this kind of capability. So you can do very complex concurrency controls. So basically call Python sub processes from Go. So all these 4 major web service components, the core is written in Go, And then the large language model strategies, this type of thing, are written in Python code. So we basically call this Python subprocess in parallel, many instances. Sometimes the same strategy can be called 3 parallel instances at the same time because of a long determinism, involved in large language models.
Right. Okay. Is this, and you did these scripts in Python to interact with the LLMs. Is that just because the ecosystem for Go libraries was not good?
Yeah, that's why was one of the reason. I think we use Light LLM. That's also a part of the semi-final. Actually, I would like to invite Qingxiao to talk about the static analysis component because she really looked into the code QL part.
Yeah. Well, actually, we are trying to use CodeQL to do the reachability analysis because, well, the main algorithm for our POV is that we are trying to rank the vulnerable functions and we input them to the LLM to ask it to patch. So it's actually very important that we find the correct vulnerable functions. And to do that, we need to do static analysis and see how the fathers can call, what kind of functions it can reach. And I was doing another project that are using CodeQL, so I was invited to do this part of static analysis in our CRS. And well, the thing that CodeQL is good at is that, well, I'm mainly doing it on Java projects, and for Java projects, there are actually many overloading functions. So actually, we are only ranking the top 5 functions and feed them to LLM because we want it to be accurate. And overloading functions mainly have sometimes it has 7 or 8 or more than 10 functions. So CodeQL actually can distinguish between the function signatures. So it's actually more accurate than we are doing it with other ways to parse the function metadata. And also CodeQL has, well, we also have other problems with CodeQL that we haven't been able to configure at the end. We did the CodeQL before when we're building the project. So some Java functions are actually built after we building the whole project. So CodeQL, after analyzes these functions, it actually calls functions that are from a Java file that hasn't been generated before. That's the problem part. But the good part is...
Sorry to interrupt. Is this due to imprecision, where it thinks that certain control flow transitions can exist even though they can't exist in practice? Or is it just due to the kind of subtlety of the build system?
I think it's just that many Java files are dynamically created during the building process.
I see.
Yes.
Yeah, this gets into what Jeff was talking about real, the academic style, software engineering stuff versus real world code and real world projects that do weird things.
Yeah, I mean, people tend to believe, static analysis is sound, but in reality, you can easily get incomplete call graph.
Faced with a build system that's not completely sane, you can end up with a lot of. What comes to mind is was it curl? SQLite. Their build system takes all of the source files and concatenates them into one giant file and then compiles that in one shot.
Yeah.
And that caused huge issues for our static analysis because the locations that were generated didn't exist in the original repository.
That's right.
Yeah, that's exactly what I was talking about.
Or I think the curl example was, didn't it do linting on the code that was generated?
Oh my god.
Yeah.
I'm gonna have to sit in a dark room again after this episode.
Sorry, I shouldn't have brought it up.
That mention.
I know, but that's one of the things.
Who the hell does that? During compilation time, they say, nope, their indentation is wrong in C. You didn't put a comment here. We're not gonna compile this code. It's insane.
I mean, it's an example of real world code, and I think that the academic community has like it's this classic academic versus engineering kind of gap, right? It's like we build ideas and prove concepts out, but bridging that gap from this cool idea, static analysis on Java, which seems like something we've been working on for decades, and then like actually applying it on a real world project and finding all these edge cases and weirdnesses where it doesn't quite work because of intricacies of build systems is kind of the core of the engineering versus, or the research versus engineering gap.
Yeah.
Yep.
Sorry, go ahead, Qingxiao. I interrupted you.
Yeah, it's fine. Yeah, and for CodeQL, we actually have succeeded in done all the analysis in less than 5 minutes because, well, that actually depends on the size of project, but mainly we can shrink the time to like 5 minutes, because we found that if we are not querying the reachability of each functions each time, because the main flow of CodeQL is established the connection of the code bases which we built before. So we just concatenate all the QL scripts together and we just query once. And we also reduce the cycle in the past and everything like that. So it's pretty fast and it's pretty accurate for Java projects.
Nice. And this is great because like I don't know, I can't remember if we've mentioned this aspect of the competition, right? But only like each of the challenges, it's not like all code in the repository is even reachable because the targets themselves supplied harnesses. So it's only code that you could reach from the harness to actually trigger a vulnerability.
Yeah.
That's kind of what's considered in scope. So like having the static analysis in order to winnow that down and if I remember correctly, so you're generating 5 target functions to then send to an LLM and say like find bugs here.
Yeah. Yes. And static analysis really helped us with identifying the location of the vulnerable functions.
That's
and
great.
You would get it where a good chunk of the time, the top 5 candidates had a vulnerability.
Yes, but actually we still need to input all the information. So static analysis is still part of the prompt that we ask AI to rank the vulnerable functions for us.
Sure. Okay.
Yeah, so the AI is still time consuming. But we don't worry that much about static analysis time anymore.
Yeah, that's awesome.
A great optimization. I don't have the numbers for Shellfish, for example, but the whole early stage preparing to fuzz stuff, like all preparing for the AI and everything, could take up to an hour and a half, I think, for Shellfish's efforts. Like it can be a lot. You know, like you said, all of the indexing, all of the lightweight static analysis can take huge amounts of time.
Yeah. Very cool.
Yeah,
Okay. Go ahead, Jeff.
Maybe I can add one thing that, kind of interesting to me. So I mentioned parallelization, right? I mean, we put a lot of effort into parallelization, parallel this whole system. So we use AI to generate code. Let's say, hey, generate this Go function that will take this, IR code, whatever the intermediate, JSON format, and then produce all the code paths starting from this entry point to a target function. So at some point, we're able to run 10,000 threads on a single node to do this as fast as possible. And another instance of parallelization was, so essentially, let's say if you build the repository, let's say give a task to me, I build the fuzzers, maybe there are 12 fuzzers, right? We build them in parallel. And then we send each fuzzer to a separate node. Say we have like 97 nodes. Those are our workers. So each node is basically responsible for focusing on one fuzzer, entry point. So then, it basically interact with static analysis service, reachability, try to cut the search space. Sometimes the static analysis fail because of some, weird issues. It would resort to a full, let's say, if this is a full mode, code base in the worst case, I tried, say send all these functions to large language model each time, maybe 1,000 function, 500 functions. I find, hey, does any of this function contain a backdoor? Right. Sometimes I think the signal sometimes is very good. If you look at the top 3 or top 5, it can identify those functions.
Wow, that's cool. Okay, so then I'd like to ask a detail about the system. This goes into the super parallel kind of thing. So are you generating POVs and patches also in parallel? So
this is actually interesting design kind of point. So I know lots of teams basically starting from POV and then patch, right?
Mm-hmm. Yeah.
And some teams use also POV and patch in parallel, right? And I believe there must be a design point from patch then back to POV.
Yeah.
I'm not sure if anybody can explore that, but our strategy is so we realize during our testing we find if we find a POV, most of the time, I would say more than 90% of the time, it happened in the first 20, maybe 30 minutes, let's say that. Okay. But if you don't find any POV in the first 30 minutes, we run it 6 hours, 8 hours, we don't really find anything. It may be because we didn't optimize our, fuzzers, well enough. But we ended up having a strategy like this. So we do POV first for the first 30 minutes. If we find a POV, good, we're going to do patching, right? We create a signature for each POV, so we can just combine them when do patching. And then let's say after, I think 1 hour or 1 hour and a half, suppose we haven't found any patch, okay? Or we haven't found any POV. So we'll fork something we call AIxPatch. So AIxPatch is something, only triggered under condition, which basically, that's patching without POV. So we try to scan, we try to use reachability, all functions to find any high signal vulnerable functions, right? We try to say, hey, any backdoors or any, cross script, this kind of thing. And I found this is particularly helpful for Java, vulnerabilities. Yeah, so I would say in our CIS, if we ended up finding anything like a true POV or true patch, we typically, do this in the first 2 hours. If we don't do this in the first 2 hours, then we don't find anything. So we tend to kill some nodes, kind of once it reach 2 hour time limit.
And this is kind of reflected, of course, as in the academic research where you have this logarithmic return on investment where, like you said, you're going to get the best results very early, and then a ton of research in fuzzing is targeted at like how can we stretch that out before the flat part of the logarithm takes effect.
How do we / can we, right? And it's kind of like the stalling out of fuzzing, which is it's and especially in the time scales we're talking about in the competition, it'd be one thing if you're running this over a month. I think you'd see kind of breakthroughs as the fuzzers are able to trigger new parts of code, but those can take days, even with large fuzzing campaigns.
Yeah, I think one challenge we had with this kind of design was when we are, say one virtual machine running one fuzzer, and they didn't have that fuzzer is not, cannot reach any vulnerability, right? We're still running it. We're also, a part of the running, we're also using large language model credits. And that's basically, I think in one of the rounds, exhibition rounds, we used all our API credits from one provider at some point.
Oh, man. Wow.
Yeah, so we realized, that's a bad design. We had to, optimize that. So we ended up, kind of optimizing something like after running a couple hours, if you don't find anything useful, I'll just kill you.
Yeah, that's really interesting. Did you tell the LLM that you're going to kill it? That can motivate them sometimes.
No, that's a hyper design.
We had an incredible...
Talking about our Russian roulette of experts idea.
Yeah, exactly. And I've used that elsewhere, but it feels so psychopathic to write AI things like that. We would have, and this is full credit goes to the students, but we'd have this panel of experts prompting approach where you tell the LM simulate 3 experts or whatever, that you let it run for a while, and then you say, someone just ran into the room and killed expert B. So expert A and C now debate amongst yourselves. And it led to good results. Anyways, it's just insane. But from your usage of like that high usage, I think Shellfish ran into that a little bit with some of the sub techniques.
Mostly on our internal testing. Yeah, we had like one component that was just going crazy with LLM usage, but
otherwise, I wonder. I'm trying to think of did we end up in and I'm sure in runtime it crashed and burned, but I think you guys are the only other team I know that like ran into LLM cost issues. Maybe. Yeah, it's more rare. That's interesting. That's a good amount of using LLMs.
Yeah. I recall there was also rate limit that was very annoying.
Exactly.
So we had to develop a fallback mechanism, actually sequence of fallback mechanism. Say if this one I tried 5 times, all failed, go to next one, repeat. There's a but I think if we're able to avoid this rate limiting thing, we would probably to find more vulnerabilities.
Yeah, it's interesting. It almost makes it, I was thinking it makes the systems even more stochastic because you have not only the LLMs themselves are stochastic, but now you have your usage of them depends on all the other components that you have, and they're using LLMs and you're hitting rate limits. So you, because you kind of took this LLM centric approach, were you pretty excited to see the shift from in the game from quals to finals? Of being able to use more resources, specifically like LLM credits?
Yeah, we didn't expect in the final they would give us so much API credits. I was expecting from 100 per task to 1,000 per task, and then there's like several tens of times more. That definitely influenced our design. We actually ended up having. So there's a combination of traditional fuzzing, leap fuzzing, FFL. I mean, the only interface is the large language model generates those seeds, which are not very successful. Then we keep fuzzing with traditional methodology, right? We actually didn't see much success from traditional fuzzing, even with this. Maybe a couple of times we found POV. For C, we never see anything for Java.
So the LLM was king for Java. That's cool. I've often heard the LLM does really well on Java, but I hadn't heard kind of that level of statistic. I've also heard that fuzzing on Java is pretty poor for a number of reasons, right?
I was thinking maybe that could be part of the root cause, right? Or maybe I don't know, the types it's easier to reason for the LLMs about Java, but yeah. Could be like a combination of the two, right?
I think there's a couple of things also. Like with C, there's just so many things that can go wrong, so many more things than with Java. So like the reasoning is much more targeted on Java. Yeah. We saw a similar thing, but we still did a lot of Java fuzzing. That's interesting. The more time goes on, the more I feel, especially as, you mentioned 90% of your code is written by AI as well. You can really feel, like Adam mentioned, a phase shift during the competition of our experiences with cybersecurity and program analysis, not just the cyber reasoning systems experience.
Yeah, so I'm maybe then we can, because that's another thing. So you kind of, betting on AI makes a lot of sense looking back, right? Because the budget expanded from quals to finals, but also the models got better. So could you talk about, did you guys have like a new model comes out? Did you have a way to test it across your different use cases? And then how did you decide what models to use for all these different tasks?
I can say one thing there.
Yeah, sure.
basically every new model, we look at this ranking LLM arena, ranking leaderboard. Every single model, if maybe top 20, we're going to test it. So any new model, comes out, we're going to test it. Or clearly models change, from 2 years ago to now.
Well, we actually want to make our CLS in the future a benchmark. Actually, you just need to change the model names and change whatever API tokens, and then you can use the latest model to test our CLS. And yeah, this is something I think pretty impactful in the future. And also, for the competition, I actually made a testing or precisely evaluation service. Like we gather some runtime information from our CLS, like the token usage, like the number of POVs and patches found, and the cost analysis and time, and a lot of different metrics into our evaluation service. And basically, it has two aspects. We can analyze it by the strategies. We can define which strategy has found the most POV and patches, and also we can evaluate in the model aspect and which model found the most POV and patches, and which model found it in a less iteration or less rounds. Yeah, we have something like that.
That's great. Awesome. Wow.
I think there's value there. Also, it sounds like your CRS might be a little easier to run than that. Well, there's a lot of parallelism. I'm just trying to think. One thing that popped into my head as you were talking about this, these things are all really cool, but a kind of limiting factors, can interested people actually get this stuff running?
Well, actually, although we get mountains of parallelizations, however, we actually have a local version of our CLS. You can run everything in a single machine. Yeah, this is pretty interesting, and this is pretty easy to be tested. Yeah.
And it's important. Did you find that that was important for development, like for your team?
Definitely, yeah. You can debug everything in one machine. Yeah, that's pretty awesome.
So did you guys, so you Jeff, you mentioned testing like, top 20 models. Did you end up using any local like models in your setup?
We tried. Actually, we actually tried. We tried DeepSeek. We tried Quen. Llama 3.1 or 2, 70 billion. We tried all of them. We found, that's a huge gap. The gap is too huge.
Yeah.
So we didn't, end up, we're not using any local models.
Yeah. I think it makes sense. Like especially if you're going all in on AI, right? You have to use the best of the best models. And it's just, it's kind of shocking to me how much better they are than the open ones.
Yeah, the gap is crazy. I think that leaves Team Atlanta as the only one that had any sort of local models. That's wild. I keep having these conversations with very academic researchers that say, but why don't you use this local model, because then you can query a lot more in depth. You can query token by token, which opens up possibilities, and it's just hard to convey that.
There may be some like
gap.
Economic price impacts because of like the nature of how long we had to run the competition, right? Like maybe if you were running the CRS locally months, like on every single commit to a huge project, it would make sense to invest in some kind of local like cluster of machines. But whereas these were, it was long competitions, but it was on the order of hours, right? Like 8 hours or something like that, or 4 hours.
4 to 8 or something per challenge.
Yeah. So, it just, and then all the engineering, the added engineering of having to get your model into Azure on the local thing to run it. Like there's a lot of extra stuff that nice token price kind of captures.
Yeah, it's very, but it worries me, right? As an open source proponent, and what's the term now? It's kind of like compute sovereignty. I want to be able to not rely on some random web endpoint that is doing who knows what, that just gives me intelligence, right? But people keep saying AI as a utility.
But Jan, your PhD students don't have a web endpoint. You rely on their intelligence.
They do. It's called Slack.
See, more layers of indirection.
Exactly. But yeah, I mean, it's maybe we're rapidly barreling, which is crazy because the field is so new, but we could be barreling toward a thing where, running your own AI is kind of like putting solar panels up on your roof. Like you can do it, but it's a pain in the ass, and like just pay the utility company they'll put up the solar panels in the desert somewhere.
Yeah, I mean, there'll probably be some trade-offs, but maybe like Team Atlanta said when they were doing fine-tuning of the like online fine-tuning of the models, maybe that would be something that to explore in the future, especially if you think about running these CRSs on not just any arbitrary like GitHub repo or OSS Fuzz repo, but on a specific repo that is your system. And maybe you can fine tune it on past bugs, past patches, human patches, right? I think there's an interesting mix there to potentially boost the performance of these local models.
And that's where, sorry, go ahead, Jeff.
Yeah, I just want to say, I think there's a huge space of interesting research can be done. Let's say we have, once we have the 7 CISs open sourced, right? Each of this is a benchmark actually for newer models, and we can produce maybe hundreds of thousands of vulnerabilities that build such databases, right? This can be turned into something like a reinforcement learning system to train the next generation models. Or bridge the gap of the existing open source models, right? I mean, eventually, that's already. I mean, the way to this is very specific domain of cybersecurity, right? Where this CIS represents the top experts, and now you have the data generated by the top experts, right?
Yeah, that's a good point. Said, I mean, I hadn't thought about that, right? Like the difference. There's the open sourcing of the system, but also the open sourcing of the contest data that, DARPA is going to release will be extremely valuable. And then the ability to run these 7 CRSs on other OSS fuzzed projects, I think would be super interesting.
Yeah. And so, you have thousands of potential targets, just 1,000 from OSS and plus historical versions, historical vulnerabilities. And that in turn produces millions of interactions that you'd like to see. You can even rank them how much they contributed to positive outcomes. And that's a hell of a fine-tuning data set.
Yeah, who's got the compute and the credits to run these?
Yeah.
Cool. Well, is there any other parts of your CRS that you want to talk about that we didn't touch on? Is there maybe some... maybe the strategy component or the game strategy component.
And then the patching would be interesting too.
Yeah. So maybe we can talk first about the component that interacted with the game.
Sure. Qingxiao, you want to introduce some POV strategies first, and then I can do some patching introduction?
Sure. Well, we have different POV strategies. We actually have basic POV strategies, which we just give the vulnerable functions and ask the LLM to find the POVs. And we run that. This is the most basic strategy, and we will run it for like 45 minutes. And if that didn't trigger any vulnerabilities, we just go on and run parallel on our advanced strategies. And in these strategies, we just give them different kind of informations like the reachability, the call path. And something we did which is interesting is that we have language specific focus because, well, we are analyzing the POVs that we couldn't trigger. And when we actually found that there are some common characteristics in the vulnerabilities in the C and in the Java projects. And we summarize them and also feed them as part of the prompts to the LLM and ask LLM to, well, focus on this kind of vulnerabilities more. And, well, we merge all the results from we actually tested different models and we merged the results because they gave scores for the different vulnerable functions, and we just want to grab the ones that are most likely to have POVs. Yes, and then we feed to LLM and ask for a Python script that can generate a blob. Yeah, that's
And
basically
that's your like
our...
that's to seed the fuzzer and finding it.
Yes, yes. No. Oh, yeah, yes, sorry. Yes, that's what we feed to the fathers and see if it triggers any run crashes.
Nice.
Cool. So once you have the crash, or when you say you don't even have the crash necessarily, how does the patching work?
Well, that's what we call the AIX strategy. Basically, for our patching strategies, we have actually 10 different strategies, but the main idea, the main framework are the same. Basically, the most important thing here is to find the vulnerable functions. And if a crash cannot be generated, then we just treat all the functions or all the functions that are called by the function the commit diff are functions. And this is somehow we can perform the further patching strategies. And basically, patching in our CIS has 3 steps. Well, the first step is actually find the vulnerable function, or what we say target function that need to be fixed. And this can be generated by large language model, by giving large language model the crash report, a vulnerability report. And if no crash is found, we can directly find all the functions in the commit diff. And then a large language model will return something like the function it wants to change, it wants to patch, and then the strategy will move to the source code base, and then find these functions and extracts metadata of each function, like function name, file path, starting line, ending line, and the actual content. And then we can let large language model to generate the full code of patch function. This is different from a lot of other teams. They sometimes generate the hunk diff file directly. We generate the full code of the patch function, and then in the step 3, we override the patch function to the original function in the code base, and we test it. Like we compiled it, we run all of the tests, and if all tests passed, we use ediff to generate the diff file. This can make sure that diff file has definitely a correct format. This is how we make the patching work.
Nice. So then, okay, you've generated patches and you've generated POVs. How do you decide which patches and which POVs to submit?
Well, basically, if a crash is found, then we can directly send the crash to the patching agent, and the patching agent can read the crash report. And this part is easy, right? Because you already have one POV and you already have one patch. And for the second one, I think it just use the submission server, because submission service actually manage all the submitted, all the POVs and all the patches we found. If this task has a valid POV, we are going to see if let large language model see if this two can be combined, and we create a bundle. Yeah.
Nice.
So back to Adam's question on how do we decide to submit a POV or patch? Right?
Exactly.
We had gone through multiple iterations of our design. We ended up having, say, we generate a signature from each POV. So if 2 POVs have the same signature, we just submit, the first one, right? If they do not, we have a second check to use large language decide if, they look, indicating the same vulnerability, right? I think we had a limit of maybe at maximum 5 POVs, different POV signatures or something like that. Okay.
What goes into a signature? Is it stack traces? Is it the function, all the above?
So the signature was generated based on the stack trace. We use the large language model. Well, we had a kind of a hybrid thing. If we can find a file name and line number, or something like that, we
Mhm.
would extract directly. Otherwise, we'll use large language model to generate something like that. And this signature is also used for us to produce the bundle.
Interesting.
Yeah, and you can get the signature in the same way from the serif as well.
Yeah.
For the static, that's cool.
Serif is also, I think we can probably write a page in the paper on how we did, how we deal with serifs, because sometimes the serifs was received kind of later than POV is already generated, right? So we have to match if that serif is the same as POV.
Yeah.
And we had a majority vote. I think we employed 4 different models to check if serif is valid, true positive or false positive. And if there's a hybrid, if there's a mixed decision, then we would have to go through the POV generation, taking the serif as input. So
Exactly.
yeah, it's kind of complex, fairly complex in the end in the handling of serifs.
So you use the serif to create a
POV.
Oh no, the POV to create the POV if you don't have a triggering input before you get the serif.
And that's one condition. The second condition is if there is a mixed, kind of decision from the, I think, 4 different models. If
So you ask the 4 models if it's a true positive or false positive.
Okay,
and then
I
if
see.
not, or if you don't get consensus there, then you
try to
generate a POV.
Generate, the POV,
even for that, we found fragile sometimes. There were some models, they sometimes perform really well. They're very accurate. Sometimes they're just not good enough. Sometimes we hit the rate limit. We had the fallback model. Even those parts was, kind of not very reliable.
Yeah, that's fascinating.
It's fascinating. Yeah.
Yeah, it's like I think more evolved and more complex version than Shellfish is. Ask the LLM once. If it says it's a vulnerability, then say it's a vulnerability. If not, wait, and then maybe you get a POV and you can try to match them up later. But I don't think we actually do anything. I don't think Shellfish derives any data from the serif itself to try to generate a POV.
Yeah, we had to ask the models too extreme, right? I mean, what is this serif a true positive? If all of them say true positive, good, we just send it, hey, true positive, right? Mm-hmm. If this is the mixed results, we're going to go through the POV generation with the serif. And then if not, for the other case, we're going to ask, hey, is this definitely false positive? If all, false positive from the 4 different models when report false positive, otherwise, we tried various different design decisions. This is the kind of very complex end.
Yeah, it reminds me a lot of like when we were trying to go through what our strategy was going to be for patch submission and POV submission and deduplication. And when we there was anyways, we had all this discussion, and I think it's kind of similar. Like that strategy ended up very complex. But if you look at the reason why, I think it was all like a reasoned approach, but you end up with this complex series of decisions, all from very simple decisions. Like, okay, well, if it's this, we should do this. But then there's this case we need to handle, and then this other case, and then finally that 4th corner case is very, very tricky.
There's an emergent complexity that just goes off the rails, and it's completely unexpected. I mean, except for it happens every time, and so we should be prepared for it. But every single time, we're going to start over, and we're going to do nice, simple things. Keep it simple and stable.
Yeah, and I think I think from a game theory perspective, right? I think each team, at least the way we were thinking of it, is we'll kind of, we assumed most people were using the same techniques, so we're all going to kind of find the same POVs and probably generate the similar style patches. So you're hoping kind of that these little decisions would kind of make or break, differentiate you a little bit from other people. But whether that actually is true or not is the big question.
Yeah, I would say part of the complexity was caused by the inconsistent reliability from the models.
Yeah, this makes sense, right? You're having to explicitly deal with this in probably several different places throughout your whole system, right? Yeah. That makes sense. Okay, great. So then I've been asking this. I actually think I know the answer already, but we'll see. So what would you consider to be your CRS's secret sauce?
Yeah, I would say parallelization. I really love parallelization.
That's what I was gonna say. That's what I was gonna say.
Yeah,
Anybody else have any other
definitely.
thoughts?
Yeah, I would say the same. Yeah.
Yeah, me too. It's...
About the super fast static analysis. That's pretty good too.
Yeah. Yeah, but that's not the biggest secret sauce.
But if you do best on Java, then you can point to that and be like, that's our secret
Okay,
sauce.
I will. Definitely.
Great. Awesome. Cool. Okay, so then I think this is probably maybe the most relevant for your team. So how has your outlook on AI changed during AICC? Like from the start before quals till now?
Well, before joining in this competition thing, I was quite skeptical about AI's capability in vulnerability detection and patching it. And actually, at that time, the code generated by large language models contains many bugs, right? And many of these bugs were quite hard to spot. Actually, you just find a little silly bug in a well-structured code. Well, it's pretty hard to debug. But participating in this competition changed my idea with the support of good software engineering practices, combined with a lot of large language, which has a much better capability. I've seen that the models can actually find vulnerability and fix them. And also, which is pretty impressive, the fully automated CRS. And we can make everything automated. This is pretty cool to me.
So let's dig into this a little bit. You mentioned 90% of the code was written for the CRS was written by AI. The CRS harnesses AI and a couple of traditional techniques to find autonomously, like you say, bugs and fix bugs in software. So it's 10% of human effort left. What is that?
Whoa.
And
that is a gross misuse of statistics, sir.
I
don't think you can say, when they say 90% of the code was generated by AI, that doesn't mean they clicked one button and out popped 90% of the code.
Right. Okay. So what's left?
Good.
What else do we have to automate away so that maybe you just need one prompt, develop a cyber reasoning system for maybe even this specific application and so on? In your view, I realize this is kind of a futurist kind of silly question, but given how much you guys use AI to write the CRS, I'm interested.
So, I'll say something that I remember, and then Jay can go ahead. What I found most surprising was the capability of AI for generating code. The speed of, if you look at 2 years ago, it was not so good, and now it's super good. I think every time now, before I write any code, I would ask AI to generate that code for me. And typically, I do it 2 times. The first time is, hey, this is my description of the function I want you to write about, right? I typically don't ask AI to generate a huge file or something. I just want, hey, this is a clear function, please write it. Maybe 100 line code, 200 code, don't too much. And then I test it. If it's good, I'm going to accept it, right? Or manually just to copy paste generate code to my cursor environment. And then I want to parallelize it. Say, hey, this is the sequential version which is working. Generate a parallel version in this particular language. I would say more than 80% of the time, the first 1 or 2 tries, it's already working very well for me. Now back to your question, the rest 10%, right? It's debugging. Sometimes I ended up with something very weird. I remember there was a time we submitted wrong POEs. That POE is absolutely false positive. Okay, then we look at the log. We spent maybe a day or 2. Very high dense time. We realized, this was due to a race condition.
In your parallelization, or
in the 2 levels parallelization. One is function level threads parallelization. The second is processy level. The debug actually was on the processy level parallelization. So let's say we have two parallel instances. The first one generated a valid POE, which stores on the file system under this directory, this name. Actually, the name includes the timestamp as well. But it's just unfortunate, the second parallel instance generated exactly the same file, which is an invalid POE, and we were kind of incorrect, or AI generated code was incorrect to place them in the same directory. So that actually cost a lot of hours debugging such an issue.
So the secret sauce cuts both ways.
That's true. That's very true.
That's true.
So debugging was a very, very challenging.
So that's a human thing that's still like that. Those levels of insanity. Because I've seen like Claude Code debug pretty well by putting in debug statements and observing output, but this feels like beyond it still.
It reminds me a lot, Jan, of when we've tried to use AI to maybe generate like a outline of a paper or proposal or something, and then it ends up looking almost too correct. Like the sentences are all good, the grammar's all good, but the logic is just not right throughout. And so it's sometimes even harder, like you were telling me, because it looks so good otherwise, that it's hard to really dig into why that logic, because it does sound like almost like a logic problem, right? Like this race conditions is also a complex, subtle logic problem. And so seeing that it can also have that in writing, I think is pretty interesting.
I would say this also had some human factors involved, right? So let's say 2 years ago, when I started using AI generated coding, I was very careful, right? Hey, for any line of code, I would review very carefully, right? And gradually, I have built confidence in the AI generated code. So now, if you generate 200 lines of function for me, I'm just going to test once. If it works, I'm going to accept it, right? I would not spend time, digging through little details. So then, if this is a bug involved, I'm not familiar with the code actually, right? So that takes long to debug.
Yeah, I've been noticing this recently. In the wake of the AIxCC, I've also embraced this vibe coding thing, and generate. What's really interesting to me was that as a professor, it can be very challenging to stay involved in code, in writing code, because the students do it fast with more ability to dedicate a lot of time to it, whereas the professors get pulled into all sorts of directions, and I'm sure
their thinking time, their thinking time is much larger.
and
Hopefully.
The rise of the coding assistants has been pretty interesting in this. I've been pumping out a lot of code recently, which is something that is hard to do in your career normally.
And is it good code? That's one of the big questions, right? I think.
Right. I don't know. I don't look at it. But the test cases pass, and I do look at the test cases. So it's
terrifying,
very interesting.
Terrifying.
Yeah, it is terrifying. But like Jeff said, you learn to trust it. Like it works.
Mm-hmm.
You glance at it every once in a while, like, yeah, this looks reasonable.
Yeah, it all depends on the I think, as I can't talk about it too much, but which we'll I'm sure talk about later, but you start to like get more of a feel for what stuff you should really look at versus not caring so much, like you're already doing, right? Of like, okay, if you've convinced yourself, if you can verify that the tests that it's writing are actually testing the things you told it to do and the functionality is correct, then you're good, because it's not cheating, and you kind of, if it's a minor feature, you don't really care. But if maybe it was a core feature, you would like actually invest time in both to make sure. So yeah, I think it's interesting.
Yeah, it also depends, like the failure modes, right? The stuff I'm writing, research prototypes, if they crash and burn, or they have security flaws, it's not the end of the world.
Right. It's not $4 million on the line and like a CRS that you need
now the
to
stuff
work.
Jeff, and Qingxiao are writing with AI, that's a lot of money on the line.
Yeah.
So,
great. Oh yeah, go ahead, Jeff.
Sorry, now I remember one thing I found very annoying was we had these two languages, Go and Python, right?
Yeah.
I find debugging Python code is really, really hard because when it crashes, it just crashes silently. Let's say if we missed a parameter, say there's 7 parameters in this function, and when we invoke it, it just provides 6. We missed one, and then crashed very silently because we had a huge amount of log. If you run it once, maybe 8 million whatever bytes of megabytes of it's very difficult to find out those things.
Yeah, exactly.
Yeah, I think the choice of language is also because I have to say I'm not personally super familiar with Python, right? And I tend to use AI to generate more Python code for me. And then I ended up spending more time dealing with such bugs.
Hey, and now you're familiar with Python.
Forced to. Yeah,
I would say I like Rust a lot more, than Go or Python. It's just for the speed of development, I chose Go and Python.
Yeah, it makes sense.
The story of the AICC, like the CGC before, it's really been Python. So it's interesting. And everyone complains.
A lot of
no
that
one can get away.
Tied to the LLMs though, because this is like completely different world that we're in now. Like you would think it would be easy. Like the reasons people chose Python and CGC is not the same that they're choosing it now, which I think is super interesting. The other thing I was going to mention is what really reminded me and gave me flashbacks about trying to find errors in this complex distributed system. We had similar problems when we were running DEF CON Capture the Flag and running an attack defense system where you have patch submissions and a database running and you have all these different components. Thankfully, we had people in industry on our team, so they were able to tell us like, hey, you should probably use something like Splunk to collect all the logs. And then we had somebody else that wrote a Splunk query to look for any errors and exceptions that would pop up. And then that would pipe to a Slack channel so we could actually watch in real time, because exactly the same, random failures happen, especially on this like multi-core distributed system. It just gets wild. And so I understand now much better about why industry develops what I think is all this complexity, but of course it's there to manage the complexity of the systems that they build. So yeah, that's cool. Okay. Yeah. So speaking of, the $4 million question. So what place do you think your CRS is going to get?
Yeah, it's a very hard question, right? Difficult to predict. I've watched some of the videos. I think
nobody said first place yet. I don't think. I think everyone has said maybe, but you could say first place if you really believe it.
I would say whoever is the luckiest. Who got more luck from the randomness of the models were likely to be in the top 3 place. And then whose system is more reliable among those top 3 probably get the winner. I wish we could be, placed within top 3, but really it's hard, very, very hard to predict.
A part of this is that we didn't interview teams in the CGC, but, there's definitely a feeling of, holy cow, everyone's taking this so seriously, which makes it very difficult for someone to say, we're going to get first.
Yeah, I think actually, now that I'm thinking about it, I think probably my ideal outcome is probably like the luck that Jeff was talking about, right? In that like, if one team wins because in some sense they're lucky, right? So either the challenges they happen to get, they were good on, the models were good to them that day. That means that everyone was pretty close together in that band, right? That like, I think a good situation is if everybody submits a cool CRS that works and they all find stuff. And then the differentiator between 1 through 7 is just some combination of like, how things went that day. I don't know. That's pretty competitive. Like I'd much rather a competitive situation than like, I don't know, getting last place. Like 4 CRSs don't work, right? And like the bottom 4 don't do anything.
It's a great situation for the contest and for humanity probably, but not for the people whose CRSs work necessarily.
I think I disagree. I don't know. We'll see. Maybe you'll talk to me in Vegas. We can see if I still feel that way. But I do, it's like the, playing sports and stuff and getting, playing in a tournament. Like, do you want to lose to the person that got second place or that got first place? Like, I'd rather lose to the guy that got first place because they did really well. Like, I don't know. Like, if you're going to lose, might as well be a close race, right? Like a photo finish. And you can say, man, we were like right there. And if things had gone differently, maybe we would have been in first. But like, if you're getting blown out of the water, I don't know. Like,
Yeah, I actually wish they could have all the 7 teams as winners. Then they just average their awards to divide by 7.
Yeah. Someone was brainstorming this. We build a pact. All the teams come together and say we'll split the prize pool.
I've heard there's some controversy in the poker community because some players did this in the finals of this giant tournament. So it went down to the 2 of them and they just agreed to split the money, and one person basically gave up and the other person won. And so it's this big thing of like, do you want that? But yeah, that's not a bad, that's guaranteed $1 million per team. I don't know.
For people that think about expected values of hands and stuff, this makes a lot of sense.
Right. Yeah.
And
Cool.
I think there's what we decided there's like 1.2 something per team. It makes a lot of sense. I mean, everyone walks away with $1 million. That's
We'll see what happens
compelling.
Thursday night. Maybe some packs start getting made. But
exactly.
Great. Okay, so now that we've kind of done this, you spent this time on this competition, built this team, built this system. So looking back over the last 2+ years of doing this, what is there anything you'd have done differently or approached the competition differently?
Joe, you like to go?
Yeah, I think I would like to improve the testing part. Even I have a testing service framework. I have a evaluation framework, but that's not enough. We're still facing mountains of bugs, vulnerabilities in our CIS. Yeah, that's the point. We actually spend more time on debugging than focusing on POV and patching generation in the last maybe 1 or 2 weeks, right? And yeah, I heard some dangerous story for other teams. Yeah, like
Okay,
Team
this is a
Atlanta.
great segue. So I can ask you this question. I should have been asking every team. Because the Team Atlanta had like a kind of crazy bug, and
Yeah.
I was chatting with Tim from Theory mentioned when I was talking about bugs he said the last bug that they fixed was a deadlock in a very critical component, which would have happened if they found too many bugs too quickly, and they found it during the very last test run that they did. So I will ask you, what was the last bug that you fixed in your CRS before the submission?
Well, it's a kind of for me,
check
it's
quickly.
an edge case. It's an edge case when parsing it's a Python file that large language model generates, because sometimes when large language model tries to generate a Python file with special characters, it sometimes generates a wrong Python file that cannot be run by the CRS. So this is kind of optimization I made. Yeah. Anything you want to add?
Anything you would have done differently over the last 2 years?
Okay, back to the question. The last bug. Just
Yeah,
look at
please.
our,
Yes. Great. Oh, this is
commentary.
amazing. I love it.
It was return code fix. So I think there are 3 or 4 Python files return code which indicate whether POV or patch is successful or not. It changed from 0 to 1.
Wow. Awesome.
Something like that.
No.
Hi.
Hey, buddy.
Oh.
I'm not sure you can hear us, but yeah, we just got a mini Zardus pop in. No mohawk though. How are we supposed to know that it's your kid if he doesn't have a mohawk?
Yeah, it's what I like is his little like ruffles here stand up sometimes. It's a start of a mohawk.
Nice. The concept of a mohawk. Cool. Okay.
All right,
So any other things that you'd have done differently? Sorry, I want to make sure Jeff answers that.
I mean, we actually, I would wish we could build some testing debugging infrastructure before we went into too much complexity. That's probably one thing. And if I knew we're going to have this so advanced model today, I mean we were using Opus 4, GPT 03, right, Gemini 2.5. We knew that 2 years ago we would have saved tons of code debugging, testing, on other models.
Yeah.
I think mostly it's really about engineering effort that would significantly cut our engineering hours.
Yeah, that's interesting because there's this tension, right? I mean, you need like the testing part to make sure everything is stable and good. But at the same time, if you overinvest in testing, maybe you find out different models are better, or you kind of have to be flexible enough in your situation, because in some sense you're building on quicksand, right? These models are constantly changing and getting better and different, and maybe more reliable in some ways, but less reliable in other ways. And so other techniques that you use to stabilize them don't apply anymore. Like, it's kind of a crazy wild, wild west.
In some sense, the philosophy seems to be build for the AI that you want, not the AI that you have right now, which is insane, right? Because if I build for the CPU I want, the progress isn't so fast. It's so fast, right? But I guess I wonder if other undertakings of building these crazy large systems, like I'm sure that if you start out right now building a video game that's big and ambitious, you want to build for the GPU you expect to exist in a couple of years rather than the ones that exist right now, right? Maybe this isn't like so unique in software development.
I think I don't know, it's just, yeah, it's very difficult to predict where things are going, right? And I think personally, I think these models today are well surpassing what I thought they would be able to do, a year and a half ago before we started this.
Agreed.
Yeah. Jeff, you mentioned like 5 or 6 advanced models. What's your favorite AI?
At some point, I recall it was a theory mentioned the Claude 3.5. We actually we loved the 3.5, and when 3.7 was announced, we compared a little bit. We found 3.7 was kind of more better in terms of POE. I think we also used GPT 4.5. That was kind of interesting. We found, although it was slower, although it was more expensive, but was consistently better than some of the other models, right? So we used GPT 4.5 until we realized, it will expire during the middle of the final.
Right.
Yeah.
Yeah, but we ended up actually using, I think we used we used a lot of models, but there are 4 models we used consistently in the end. 3 plus 4, 3.7, and we also used Gemini 2.5 in one of the components.
Wow.
We found
that's pretty rare.
In some cases, it could identify a vulnerability that the other models could not.
That's really impressive. Yeah, I think very few teams used Gemini. Honestly, mainly due to the fact that it was hard to set up and run, and the rate limits were a pain to test against. So most teams just didn't do it, it sounds like.
Gemini, unlike the others, existed when the AIxCC started, and they got better. Gemini, in terms of API queryable in its current form, didn't quite exist, right?
Right. So,
I think that was the big differentiator. It's not that you could build something in 2 years ago and then just update it.
Yeah, I think Light LLM does not support Gemini directly. We had to use different format.
Pipeline to.
Interesting.
Yeah. Cool.
All right. Well, thanks so much to All You Need Is a Fuzzing Brain for joining us today. We'll hopefully, I guess we didn't ask, but you all are going to be in Vegas to
definitely
be there. All right, great. So we can all be celebrating our, however it goes, however that competition goes, we'll be there to discuss it. So yeah, thanks so much. I'm Adam D. You can find me online at Adam Dupay. He's Zardus. You can find him online at Zardus. Together we're CTF Radio. You can find us online at CTF Radiooo. You can send us questions through email at ctfradio@gmail.com, and your questions may end up on a future episode of CTF Radio. Take care and happy hacking. Bye.
Bye.
Bye.